Hello everyone, and welcome to 7th grade math module 5, Statistics and Probability. In this video we're looking at lesson 11, conducting a simulation to estimate the probability of an event. Our learning goal is to make sure we can design a simulation using colored disks and random number generators. This will help us to master Standard 7 SP8, find probabilities of compound events using organized lists, tables, tree diagrams, and simulation. Before we get started, we are going to be talking about simulations and models here. So a probability simulation is the use of a random number generator to generate outcomes consistent with a probability model. So we're just sort of representing what could really happen in our simulation. A probability model is a mathematical representation of a chance process defined by its sample space, events within the sample space, and the assignment of a probability for each and every event. So that's just how we've been looking at probability with math so far, and the simulation is trying to represent what could happen in real life, because real life is random and doesn't always work the way that we expect it to when we're just looking at the numbers on papers on our probability model. And then we'll also talk about trials. A trial is just a part of a simulation. And within that simulation, it is the set of events that we are looking at. So when we're running a simulation, there are a lot of things that we could use to represent the random outcomes that could happen in real life. We could flip coins, we could roll dice, we could pull cards out of a deck. But another option is to put cubes or colored discs into some sort of container, mix them up, and then pull one out. So we're going to look at that strategy first. So for example, if a basketball player typically makes 5 out of 8 foul shots, then a colored disc could be used to simulate a foul shot. A green disc could be if they make the shot, a red disc could be if they miss. So you could put 5 green and then 3 red discs into a container, since there were 8 total and they make 5, so 3 would be the miss. And if we mix them up and if we choose one, that could represent a foul shot. And the color of the disc, if it's green, then that means we make it, and if it's red, then we missed. So this just simulates one foul shot. So if we use colored discs, let's try to do something like that, but instead of doing it for the basketball player making their foul shots, we're going to use it to describe how one at bat could be simulated for a baseball player who has a batting average of 0.300. So that means getting a hit 3 times out of every 10. We could actually just read that as 3/10. So you can pause the video here and try to write what colors you think we should use and what would be represented by those colors. So if we follow the pattern of our last example, green could be when we are getting our hit at bat, red could be any other thing that happens. But since we're 3 out of every 10 times as a hit, we would put 10 discs into the bag to represent the total number of possible outcomes. 3 could be green to represent how many are the hits, because 3 out of the 10 are hits. And then 7 could be red or some other color, and that would represent anything that is not a hit. And if we just pull one at random, then we could see what the potential result could be for going at bat. So now you can try this again, but this time instead of doing it for a batting average of 3/10, try it for a batting average of 273 thousandths, which means that the player is going to get 273 hits out of 1,000 hits 1,000 at bats. So our strategy for this one here is identical to the last one. The only thing that's changing are our numbers. So instead of putting in 10 discs, we're putting in 1,000 discs. Instead of 3 being green for the hits, 273 would be green for the hits, since that's how many out of 1,000, according to our probability model here, would actually be hits. And then the other 727 would be red. If we pull one at random, that's our at-bat. So, I mean, that seems pretty straightforward to talk about, but is it really practical to get 1,000 discs or something else colored and then have count out 273 of one color and 727 of another color? Not really. So instead of using discs for something that has a bit of a larger set of things that we need to work with, we can use a different strategy. So next we're going to look at using random number tables, which can be more useful when you're looking at a wider range of numbers. You can find lots of random number generators online, random number tables. You can actually use dice to generate random numbers. But so we have here a set of random numbers. It's just spaced every 5 digits to make it easier to read, although with this problem, maybe every 3 would have been a bit easier. So if we were going to use this random number table to simulate the at-bat for that 273 thousandths hitter from that last example, we could just pull out 3 digits from here and have them represent what happens when we go at bat. So since it was 273 out of every 1,000, then the first 273 numbers, which would be from 0 to 272, could represent a hit, and then all the rest of the numbers would be a non-hit. So we do, when we're working with random number tables, have to figure out what to do with our 000 number, which will pop up. You could find it easier instead of putting it at the beginning and having it count for a hit in this situation. You might find it easier to put it at the end where 1,000 would go instead of where 0 would go. And in that case, it would be 001 to 273 could represent a hit. But we'll stick with what's on the screen for this example. So now that we have this, if we continued on, what would be the hit and non-hit outcomes for our at-bats? So like for the first 2 at-bats, I went through and I sort of colored all these in. So our first 3 digits are 252. That's below the 273 threshold. So that was a hit. But then our next set of 3 digits, 566, is above 273. So that is a miss. So if we look through just at our first 8 outcomes, most of them are misses and 2 of them ended up being hits. So now that we have this tool here, what we can do with it is we can try to run a simulation for this situation. So a batter typically gets to bat 4 times in a baseball game. So we're going to keep in mind that 273 thousandths hitter from our previous example, and we're going to use these steps to try to estimate the player's probability of getting at least 3 hits, so 3 or 4, and 4 times at bat. So the first thing we need to do is figure out what a trial for this problem is going to be, our set of events. And it actually tells us at the end of this word problem what our set of events is that we're looking at for our trial, and it's 4 times at bat. So that 4 times at bat in our trial would be 4 3-digit numbers, which I copied and pasted our first 4 3-digit numbers here, and we can see that we had 252, 566, 520, and 572. So those 4 numbers together would be my first trial. So then for B, we're going to describe when this trial is a success and when it is a failure. So that comes from right before that in this word problem when it says at least 3 hits, that 3 or 4 hits from those 4 times at bat. So that's all it is. Our success is getting 3 or 4 hits in that trial. So in that set of 4, 3 of them or 4 of them would have to be hits. A failure would be getting anything less than 3, 0, 1, or 2. So if we look back at this first trial as an example, that was a failure because we only had 1 hit. We needed 3 or 4 for this trial to be a success. So now that we've described what's going to happen in our simulation, we said what a trial is going to look like and how we know if it's going to succeed or fail, we can use that to then simulate 12 trials. So I just copied and pasted from above that random number table. I drew some lines so it was easier for me to see which 3 numbers went together. I separated each of my sets of 4 numbers out so I knew which ones were my trials, and I colored them for hits and for misses. So when I take all this information and put it together, out of my 12 trials, only 11 was a success. It was the only trial that I had that had 3 or 4 hits in it. So using these results from our simulation to estimate the probability that a 273,000 hitter gets 3 or 4 hits in times at bat, we just find our probability as usual. So I'm going to take my number of successes, in this case 1, and my total number of trials. So instead of it being just one of what happened out of however many total options there were, that's the number that we had up here, the 273 out of 1,000. So instead of doing that, I'm looking at how many of my trials. So the number of successes divided by the total number of trials, which would be 1 divided by 2, which is 0.16, with the 6 repeating. So what does this make you wonder about designing a simulation for some sort of probability model? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learn from your failures, then you succeeded.